Now let us take another question. We have to prove that this determinant equal to 1 minus x square into this determinant. Again here in the determinant on the left hand side, the elements are what? In the first and second row, elements are the sum of two quantity, where in this determinant all the elements are the single quantity. And here 1 minus x square is common factor here. So let us see how to do the question. By applying operation on the determinant on the left hand side, we want this determinant. Now here what I have done here in this question, here in Ax it is Cx, it is Px. Now I have multiplied the element of the first row by x. If I am multiplying inside, then I have to divide it. So it can be written as 1 upon x, multiply each element of the first row by x. We are getting Ax plus Bx here, Cx plus Bx here, Px plus Qx here, and the second row and the third row will remain the same. Now the next operation I am applying here, operating R1 to R1 minus R2, so that this quantity will be cancelled. Operating what? R1 to R1 minus R2, then we are getting, when we are subtracting these two elements, Ax will be cancelled, B common, we are getting x square minus 1. Similarly here we are getting D into x square minus 1, and here we are getting Q into x square minus 1, and this quantity we are looking here. Now I can take here, because the quantity is 1 minus x square, here the quantity is x square minus 1. So I am taking here 1 minus x square common. When I am taking here 1 minus x square common, this x as it is, we will be left with minus b, minus d, minus q, because I have taken 1 minus x square common. Second row and the third row will remain the same. Now here in the next step, again these elements are converted into single element. These are already into single. Now we have to convert them into the single element. So let us see what we are doing here. Now here again what I am doing here, operating R2 to R2 plus R1. Then it will be converted into the single element. Then operating R2 to R2 plus R1. This quantity will remain as it is. First row will remain as it is. When we are adding these two rows, we are getting here Ax, Cx and Px. Third row will remain as it is. Now we can easily take seat here. Then this minus can be taken out. 1 minus x square upon x as it is. Now from the second row we can take x common here. We left with b, d, q, and here we are getting what? ACP and UVW. Now this x will be cancelled out, and here now the determinant on the right hand side, that is given only we get when we are interchanging these two rows. Then we are getting the determinant given on the right hand side in the question. Then interchanging these two rows. Again, when we are interchanging any two rows, our determinant will be multiplied by the negative sign. Now negative into negative, positive, it is what? 1 minus x square. We left with these two interchanging these two rows. It is what? ACP, it is what? BDQ, and it will be UVW as it is, that is equal to your right hand side. Now here earlier 12th class students, I have already told you this exercise and this type of question are very much tricky. No any formula is used. Only you have to apply the operations. It requires the presence of mind, and we have to look the determinant given on the right hand side. According to that we have to apply the operation, either to get the given determinant on the right hand side, or you have to get the maximum number of zeros in any row or column. In the last step we have to expand it in generally 80 or 90% questions. So this exercise is very much time consuming, so I needs a lot of practice. So I have taken this exercise in the last. You can devote much time for this exercise easily. Now this is all about today. Tomorrow again I will consider some question from the miscellaneous exercise, and then on from Monday we start the new unit. Then easily you can complete.